Retos 1, Retos speaking.
Pressure coming here, pressure coming.
We're 1.5 below.
Stand by, 2 dives here, boys.
We're looking at 10.5 to 42.
Welcome back, podcast listeners, and a huge thank you for tuning in. It's great to have you here for this, the second part of our two-part bumper America's Cup Design Edition. As you'll know, we sat down with 4 of the chief designers from each of the 4 America's Cup teams to really get under the bonnet of the new exciting Cup class, the AC35. I hope you all enjoyed part 1. If you've not had a listen, maybe spin back a bit and take in the first part. It's an important intro into the class, the design parameters behind the 75-foot monohull, the general approach of each of the design teams, as well as a compelling look at why the 4 boats currently out being tested all look slightly different. So it's a good introduction to the issues we'll go on to discuss here. Over the next hour of chat, we're going to listen to our 4 designers talk in some more detail about sail configuration, foil design, and we discuss power generation and control systems, and then go on to look at sailability, how easy it is for a design team to end up building a mathematically immaculate boat that in turn ends up being impossible to control. We discuss performance. All 4 of the teams have been clocking up testing mileage out on the water, so we take a look at how things are going for each of the teams. And I then finish by asking which area of design, which element of the AC75 do each of our designers think will be the most crucial part to get right. It's a fascinating look into the secretive world of America's Cup design. So again, a huge thanks to each of the teams and the designers we interviewed for their time and trust. It's much appreciated. I hope you enjoy the time I spent with the design teams of AC36.
You are picking up a yacht which, including its crew, weighs 7.5 tons.
There's always a mismatch between the optimum that you know you should achieve and what you can get in the water.
The 4 solutions for the foils that we saw are all quite different.
We're going to kick things off again with a question for Dan Bernasconi, Design Chief for Defenders Emirates Team New Zealand. At the time of recording these podcast interviews, the wind limits for the Challenger Series and the Cup match itself were still in discussion. So I started our chat about foils with a question to Dan about wind strength. What wind strength it would take to get the AC75s up on the foils, and how much of an issue is it to be building a boat that will foil nice and early?
It does depend what sails you've got on the yacht. There's a range of head sails you're allowed, including a Code Zero, and a Code Zero certainly gives you a lot more power, enabling you to get up on the foils earlier. Whether it's a significant factor in the race depends very, very much on the weather. So if we end up racing the final races of the America's Cup in 7 to 8 knots of breeze, then however fast you are in a straight line may not matter, and it may be the boat which is able to get up on the foils first, which is the winner. But on the other hand, if you've got 12 or 15 knots of breeze, then both yachts in a race will get up very, very quickly on the foils, and then it's probably far more down to straight line performance, upwind and downwind, and ability to get through manoeuvres with minimal losses.
Foil design, and in fact their composition, were a key factor in Emirates Team New Zealand's winning edge in the last Cup in Bermuda. But while the foiling multi-hulls of AC35 utilised L-shaped foils, the AC75s are running a pair of T-shaped foils, all of which have been very visible while out sailing. Comparisons of each foil design are easy to see online. So talking in more detail about the foils already being used and the issues in their design, my next questions were to Italian Team Luna Rossa's design coordinator, Martin Fisher. So Martin, let's talk foils. The foil arms are being supplied to each team, built in fact by Luna Rossa's manufacturing outfit here in Italy. How different are you expecting each team's foils to be?
Well, we saw so far from the 4 teams, 3 teams opted for foils with bulbs, like a bomb, let's say, in the middle. And one team, Team New Zealand, opted for foils without bulbs. So that's the first big difference. And then even within the teams that went for foils with bulbs, we can see that the size of the foil wings, let's say, and the bomb or the central bulb is quite different. So obviously, I would say there's even we see the biggest differences, almost bigger than in for the hulls, because I would say the four solutions for the foils that we saw are all quite different. So it's a wide range, and then of course there are lots of details that we can't see from photos. For sure, all the teams worked very hard on the sections, and the section shape depends a lot on the assumption you make on wind speed, boat speed, etc. So, but those things we can't see. You can't measure that precisely from photos. So there are many things that are very different, and the big differences in the plan forms of the foils clearly show that also the section shapes are very different.
How interesting is it to see the other boats' foil setups? Because of course now you can. Of course it's very interesting. We are looking a lot on what they are doing. It's very important to see what they do, how they do it, how they maneuver, at which speed, boat speed they take off, how fast they go in different wind conditions. We are not allowed to measure with radars or something like that the boat speed they have. So the only thing we can do is drive next to them with a rib. But that gives already a good impression and gives an idea, although the precision of those measurements that we can make is not enough to really assess their speed potential. But it gives a good idea. So just in short, we spend a lot of time on observing them. I next asked British team, Ineos Team UK's design chief Nick Holroyd, his thoughts on the foils seen on the AC35s to date. Nick, talking foils now, they're obviously very much on show while the boats were out sailing. What are the main differences we've seen in the current design of the foils?
I mean, the single biggest difference, I think, is planform area, which drives. I mean, at the end of the day, you are picking up a yacht which, including its crew, weighs 7.5 tons, so you're generating a relatively fixed amount of force. You get to play with that force vector by canting the foils and what have you, and trading side force for vertical force and so on. But in general, we're all dealing with similar forces, yet there's a fairly big spread in foil area. I mean, the Kiwis would be 50% bigger than the Italians, who are the other end of the scale. And that's an interesting fact in itself, and that they're, I think, all using a very similar tool set that came out of Team New Zealand from last time in terms of VPPs and simulators. So the fact that the two extreme ends of the spectrum have a certain heritage is an interesting fact in itself. So yeah, I think that's probably the biggest issue. As I say, to get foiling in light air, you need area. You need to limit your lift coefficients to some level. I think that's probably the single item that will characterise the boats, upwind versus downwind and across the wind spectrum, is going to be the choice of area.
What's been the key factors in the design of these foils?
They're complex to a degree in that the foils in the 50s was a rigid wing that we put inside a daggerboard case in the boat, and then we moved the case around. So all the control functions were up in the boat, relatively accessible. and easy to manage. And then the foil, you just manufactured this kind of geometry that you were looking for. Oh, yeah, a certain amount of structure in it, obviously. This time round, all the control is done down in the foil, as in removing flaps down at the foil. And so you're looking at things that are relatively analogous to aircraft flaps, etc., except you're operating in a fluid that's 800 times denser than air. And so your force per unit area of foil is enormous. And so you're correspondingly having to generate very large control forces in something that's thin, well packaged, etc. So in that sense, the control side of these ones is challenging, and packaging those and keeping them streamlined and everything. Yeah, so you've got hydraulics, you've got electrical sensors, you've got everything operating down in a pretty hostile environment, and that has led to maintenance, for example, being really, really high on these boats. The amount of time spent putting fairing strips back on foils and working on the paint finish and keeping hydraulics below water reliable, etc., is enormous. So it's probably an apology to our shore crew, actually, more than anything else.
We've seen that 3 of the teams have these bulbs as part of the foils. New Zealand are currently running with a very minimal foil bulb, in that they don't really seem to have one at all. Can you explain the thinking behind bulb or no bulb?
So the foils for these boats are actually a very geometrically constrained thing. Literally there's a box that they need to fit in. So that's a 4-metre span, etc. And then the second item that really constrains the foil design is to make the boats self-righting. They have said the foils have to be a certain weight and have to have their CG below a certain point. And so you have a choice, and exactly as you said it, the Kiwis have gone big enough on the foil area that they can pack all of that weight inside the actual wing itself and result with no bulb. Everyone else has kind of arrived at a solution where to get the foil wing area down, which wings are somewhat draggy. To keep the wetted area down on the wings, you reduce that foil area, and ultimately, it's like squeezing a toothpaste tube. That the remainder has to go somewhere, and so you see the bulb kind of appear, and so the bulb you see is very much proportional to the wing area that people have got. So again, you'd see the bulbs on the Luna Rossa boat, for example, are the longest by far, and their foil area is correspondingly smaller. But ultimately, you've got to store that mass somewhere.
From American Magic, we interviewed design chief Marcelino Boaten. And before going into more foil design specifics, I also asked him about his thoughts on the foil setups visible to date. Marcelino, American Magic, can you give us your thoughts on the different foil setups we've all seen from each team?
Well, it's the design rule is quite restrictive, with the foils. There's this box that you can't go out of, and what we've seen is that there's not big differences in planform shape or rondure and all this parameters that we usually work with in foil design. But there is one thing that we have seen a lot of variation, and that's the area. There's the different teams have chosen very different area for their foils, and Team New Zealand and Luna Rossa are at the extreme of this area variation, and we're sort of in the middle, and it'll be very interesting to see what happens in Cagliari if they still keep that's the same foils that we've seen in the past, because obviously there's trade-offs in this respect, and it'll be interesting to see that in the water.
Can you explain to us the different design factors that have to be taken into consideration for the foils of these AC75s?
Well, as I said, area is probably the biggest one. You can trade area for maneuverability, but obviously that probably makes a slow boat in a straight line. You know, if you're too small, then you get into trouble in light airs and during maneuvers, etc., etc. So there's a big compromise between all those factors, you know, and it's going to be very important to find that good compromise, especially for the teams for the challengers, you know, because they have to race in the Prada Cup, and the conditions could be quite different from the America's Cup. So we need to think of foils that perform well in all conditions, you know, not just in the conditions for the Cup.
Why do you say that? I mean, maybe just elaborate a little bit on that.
Well, in the time of the year when the Prada Cup takes place, which is early on in the year, you could expect to have a little bit more breeze than further on in the summer season in New Zealand. So maybe the average difference is not huge, but you could be sailing in lighter conditions in the America's Cup than during the Prada Cup.
The foils for these boats are far more sophisticated than we've seen before in the Cup, in that they have dynamic control surfaces, so carry internal mechanics. Can you give us an idea of what can be controlled on the foil?
Well, they can certainly get very, very complicated and very expensive to build. It's a very complicated problem structurally. You know, they are at the limits. And system designers need to deal with surfaces that have to move very accurately, but at the same time they deform under load because they're very close to the structural limit. You don't want to do very thick foils, obviously. So and it's extremely hard to get things to work the way you want. So it is very complicated to design these foils. Also, they have to operate at very high speeds underwater, which poses another type of problems with the water pressure that impacts the foil. So it's a very, very complicated thing, a very complicated piece of equipment, and it requires a lot of design time.
Moving on from foils, we then discussed the sail configuration of the new class. My first questions to Luna Rossa's Martin Fisherman. Let's talk about the sail setup for a minute. I mean, no rigid wings this time around, of course. Can you give us a brief explanation of what the rule is regarding the mast and sail configuration?
The rule? Yep. The rule imposes one design shape for the mast. So every team has more or less the same mast. There's also a minimum scantling, so a minimum, the structure has to comply with some minimum constraints, and the shape has to be the same for all the teams. And then so that's equal for all the teams. And then the teams are free to add a double mainsail to that. They also could go for a single mainsail, but since the aft face since the section of the mast is a D shape, so the aft face is flat and about 40 centimeters wide, all teams opted for a double mainsail. And then this double mainsail, in combination with the D-shaped mast, forms a nice wing shape, which comes pretty close to a rigid wing. Of course, it's less efficient than a rigid wing, but it's a step in that direction without all the inconvenience of a rigid wing. So, in short, the D shape of the mast is imposed, and that somehow forces the teams to go for a double mainsail.
How big an area of research and design is this sail configuration. I mean, it's often the foils and the control systems that get all the discussion. But a double-skinned soft main isn't something there's been much call for at this level in the past. How much is this an area that we may see gains made or lost?
It's a big, for us it was has been a big point. So we have a whole team, a big team in the design team working on that. We think it's really important. Getting this right for sure improves the power, so the thrust that we can use, but also getting this right and all the way how to control the sail, getting that right improves the way how we can sail the boat. So these foiling boats, especially upwind, also downwind, but to a lesser degree, require very quick reactions to gusts. So you must be able to change the twist and the power, or the twist of the sail and the power that the sail produces very quickly. And if you have a better sail, that's easier to achieve. So it's not only the sail shape, but it's also the control systems in the sail. So at the top, from the rules, I forgot that before, from the rules allow to add in the upper 4 meters basically any type of control system that you want. And also at the bottom, in the first 1.5 meters, more or less anything you want. In between, it's very limited. But especially the control systems that you can put at the top of the mast are very important because they allow to adjust the twist very efficiently.
I then asked Ineos's Nick Holroyd for his thoughts on the sail. Let's talk specifically about the sail design for a minute. I mean, last time around we had the rigid wing. This time we have the D-section mast with double-skinned mainsail. How big a challenge is this very new area for the team?
It is big, as I said. It is one half of the ledger in the design side. The tools have evolved to handle the double surface sails pretty quickly. The interaction of the sail plan with what the rest of the boat's doing, how much side force are you happy to generate on the rig, because obviously you have to resist that side force on the foil. All of these kind of interactions that you don't at some point. At some point, obviously, you have to bring all of this together and understand the trade-offs, because generating more drive force on the rig feels like a good thing. Put it in the bigger picture and it may not be. So look, it's early days. It's quite a weight constrained problem. So the boat has a maximum VCG that you're allowed to get to, and so your engineering detail has to be very good. Around the mast tube, all the fittings. We're pretty alert to the way we spend weight and where we choose to put that weight for performance reasons. The single biggest advantage of the rigid wings was the loads you had to deal with diminished substantially, because it's got structure within itself. You're not dealing with large sheet loads, and so it's kind of the energy efficiency and what the crew are dealing with. There's the performance side of the shapes. There's the energy generated by the crew to actually handle and drive those shapes. And yeah, it's just a very weight critical piece of engineering.
Give us a feel, I guess, for how much more load you're seeing with this setup than you did with the rigid wing.
Oh, I mean the wing sheet load, peak wing sheet loads on the 50 footers were maybe the order of 400 to 500 kilos. Here we're talking, loads in the rig, well, forestay loads in the rig of 15 tons. Main sheet loads that are many multiples up on what the sheet loads of the catamarans were. So yeah, big loads. Everybody's dealing with those hydraulically. So you're into the whole systems efficiency thing. How do pump efficiencies, all the valving, controlling those, etc.
Marcelino from American Magic. I mean, talking about the sail design now, what have the particular challenges been in the design and build of the double-skinned mainsail?
Well, as any new concept that's developed from zero, it's a big challenge, and we had to develop new tools. We had to develop new structure and aerodynamic models for these tools. We had to develop new systems for the sail control, etc., etc. So it was hard to get going with this. It took quite a long time, and we are learning all the time. You know, it's something that, contrary to the hull surface or to the appendages, you're gonna develop all the way to the end of the cup. So you're always learning in this area.
What kind of challenges did you have with the design?
Well, the design is obviously a new, totally new concept, and having two surfaces makes it relatively different from a single surface. You know, the control systems are different, and you try to find a way to find the shapes that your tools say that are most efficient, and it's not always possible because of the nature of the materials you're using. You know, I mean, it's just a soft sail. You know, it's not like a wing sail that's rigid and you can give it the shape that you want. Here you have to deal with something that's very different, and obviously there's always a mismatch between the optimum that you should achieve and what you can get in the water. You know, and you know, it's always hard to say, okay, this is how much we can achieve, and moving to something else. You know, that's something that's always hard to do. You know?
American Magic, of course, have a very close affiliation with Quantum Sails. How advantageous to the design process is this relationship?
It's been very important, especially because right from the beginning they've been very helpful, and they've always provided their best designers and their best tools, and obviously this has made developing the double skin surface much easier, you know, than it would have been. Obviously, it's taken a lot of work from both sides to get going, but now that things are working, I think it's a very, very good relationship, and it's making a lot of progress.
In a boat that sails at 3 times wind speed, a knot of wind speed makes a big difference.
I don't think that you can just design the quickest boat and then tell the sailors deal with it.
Although the racing is far off, our design decisions are happening right now.
One of the most talked about elements of the 2017 Cup boats was, of course, Team New Zealand Cyclists. The Cyclor power generators providing power to the systems throughout the boat, while simultaneously freeing up one crew member, Blair Took, to generate power and control the rake of the foils, for example. Power is vital to operate the boat, of course. The systems, the massive loads of the new double-skinned mainsail, and the foil and rudder controls. But efficiency of power also brings with it the ability to make choices. Tactical choices on the racecourse, requiring manoeuvres that would otherwise be unavailable with insufficient power. It is therefore a big topic that Martin Fisher first tackles. We haven't talked much about power and systems as yet. I mean, power, of course, was a big talking point in the last Cup. Can you just clarify in a nutshell for us what the rules state re power generation on the AC35s?
Yeah. In short, everything below the waterline is driven by batteries. Everything above the waterline is driven manually. That's in a nutshell how it is. So the foils and the rudder rake can be driven by battery power, whereas the sails and the rudder yaw, so the angle, that must be adjusted by manual power.
How vital do you think power generation will be this time around?
I think it's as important as last time. I think it's very important. These boats are really big. And even though the underwater part is battery driven, to control the sails and to trim the sails permanently to keep the boat in a stable flight situation requires lots of energy, and with the crew we have, we are always at the limit. So I think it's as important as last time.
Back with Nick and Team Ineos UK. Nick, regarding power generation, how important a factor do you think this will be? How crucial is the power generation aspect for the Team Ineos UK?
The power thing is always going to be important for the simple reason of if you had an excess of power, you would immediately soak it up to try and sail the boat more accurately. You know, if I can trim roll faster and sail the boat more accurately, I will go better. And so, yeah, I think these boats are going to be a slave ship in terms of physical handling. The guys will need to be very good athletes. And then, there's a huge onus on us on the design side and the system side to harvest that efficiently, all the pumps and the drive lines, etc., then distribute it around the boat efficiently, and ultimately build systems that operate efficiently.
Nick, with access to so much data, fast processors giving advanced computer modelling, all the tools you now have at your fingertips as a designer, is the danger that you could end up creating a perfect boat, but a boat that's then impossible to get around the racecourse?
It is certainly something that gets considered in design, is robustness. Okay, is there it's a problem you have with optimizers, and ultimately they can tread a tightrope in terms of design. So we do spend a fair amount of time looking at what the performance of a design is off, away from the VPP optimum point. And that's where your human in the loop simulators come into play, because necessarily the boat isn't at optimum all the time. Designing the perfect boat, I don't think there's any such thing. I mean, engineering is the art of compromise. Really, there's always some conflicting, competing ideas or requirements that you have to tread that compromise. And any given day, the optimum compromise will move. These boats, in a boat that sails at 3 times wind speed, a knot of wind speed makes a big difference to how the boat's operating. And so, the perfect boat, well, one that's good enough to win would be good, wouldn't it?
I suppose I think back to Grant Dalton's comment at the end of the last Cup in Bermuda, that they, having won, that they threw the design ball as far as they could and just tried to catch up with it, and just assumed, I guess, that the sailors would find a way. And there must be in the design office that balance between, this will create optimum pace, but actually can the guys make it work?
Yeah, and I think maybe the flip side, to come back to BAR as it was at the time, is those guys weren't optimistic enough about where they could get to with things like control, and therefore weren't pushing foil performance hard enough. And actually they, I think, overachieved to some extent against their expectations in control, and then didn't have the corresponding hardware to match that. So yes, I guess I've seen both sides of that equation, and 100% it is something you're trying to balance. I think you've got to be modestly aggressive in chasing that, for sure.
With this in mind, I then asked New Zealand's Dan Bernasconi about the role of the sailing team in the design process, and just how Pete Burling, Blair Took and Glenn Ashby were enjoying sailing this radical new class of boat.
Oh, they love it. They really enjoy sailing the yacht. I think it's a challenging boat to sail, but a really exciting boat to sail. Behaves quite differently to an AC50 or a foiling multi-hull in the time leading up to takeoff. But once the boat is actually up and foiling, in some ways it sails quite similarly. Probably, I mean, it's a bigger boat, it's a heavier boat, and once actually foiling, it's more stable, and I think potentially a little bit easier to keep on the foils than a 50. But that transition from non-foiling through takeoff is really challenging.
In such a radical-looking race boat, how important are those guys in the refining of the design process?
It's a real collaboration between the sailors and designers. The sailors' feedback is incredibly important, and as I said earlier, the work we do with the sailors in the simulator is incredibly valuable, and that conversation going both ways is really what drives the design forwards. And I think it's a really different environment to how it was when I started in the America's Cup in 2006, where the sailing team was really very distinct from the design team. I hadn't even met most of the sailing team when I was with Alinghi for the Deed of Gift until shortly before the boat was on the water, and we designed the yacht completely in isolation of the sailing team, and then the sailing team would show up and say thanks and take the yacht out for a spin. Whereas now, the sailors really are an integral part of the design team, and I think it's really cool that it's evolved in that way.
Well, back with Marcelino at American Magic. Marcelino, you have previous relationships with Dean Barker, of course, who's helming American Magic, but also team principal Terry Hutchinson. You've worked closely with Terry on the quantum racing TP52s, of course. How important a factor are the sailors, the end users, if you will, in the design process? Is your goal to build the fastest boat possible?
It's crucial, the relationship with the sailors is very, very important. It's as important as the design itself. We design a boat and they have to take it to the maximum possible performance. I mean, and clearly we can look at the numbers that come out of a day of sailing and draw some conclusions, but much more important than that is what the sailors feel, what they the feedback that they give you from what they feel on the boats. That's much more important than the numbers.
With that in mind, Marcelino, I mean, obviously the control systems are something no one can see. How important a factor are the control systems, the user interface on a boat of this potential speed and power?
It's very important because these boats are relatively stable. They're not very hard to sail in perfect conditions, but they're very hard to sail accurately when it's any sea state or when it's puffy. And so we did dedicate a lot of work to get the crew to sail the boat as consistently as possible. That's basically how we look at it, and at the optimum attitude, let's say. And in order to do that, we are very restricted by the rules, that don't allow any sort of electronic way to control the boat. So yeah, we try to be quite creative in this area. Yeah.
I then asked Luna Rosso's Martin Fisher, how much is the sailing team in the thoughts of the design team during initial systems design? Is it a question of building according to the best performance on the computer and then learning to sail the resulting boat?
It's both. I don't think that you can just try to design the quickest boat and then tell the sailors deal with it. I think it could be that you come up with something that is unsaleable. So it's always important to discuss with the sailors, to develop together with the sailors how far you can push in one direction, how close you can go to the boundaries, let's say, to the limit. And then it is important to find together this best compromise between theoretical performance and what you practically can handle.
So the systems themselves, the interface between the sailor and the hardware, how vital are these to the performance of the boat?
That's very important. The way how they can adjust or how they can trim the boat. Actually, the instruments they use are really important. We made many tests. Actually, we have, as all the teams, we have a simulator in which the sailors can sail the boat on land, so just virtually. And we tested lots of input devices in our simulator to find the best solution, how they best can control the boat. And we found that those input devices have a big impact on the quality of the control.
You've been testing out here in Cagliari. What sort of speeds are you experiencing, and what speeds, I guess, are you expecting to be able to reach?
I won't tell you exactly the speeds, but roughly upwind, the boats are doing more or less twice the wind speed, downwind about 3 times the wind speed. So that's quite impressive, and that's comparable with the AC50, although the angles are slightly better. So I expect that the VMG upwind and downwind, so the velocity made good upwind and downwind, is above what we saw from the AC50s.
How much faster do you think it can all go?
It can, that's very, I don't know. I really don't know how much we still can gain. For sure, we are not talking about knots. And we are also not talking about 1/10 of a knot, so it's somewhere in between. I don't know exactly, so I hope we can go 2 knots faster, but I don't think so. We'll see.
There's an understandable reluctance to give away too much detail on performance. Team New Zealand have also had plenty of time out testing in the waters off Auckland. So I asked Dan Bernasconi a similar question regarding what speeds they had been reaching throughout early testing.
Yeah, I don't expect any team will be willing to say exactly what speed they've reached in their yachts, but I mean it's well over 40 knots. If we wanted to break the world sailing speed record, then we would be designing a slightly different sort of boat. We've got to be really competitive in light conditions and strong conditions, and we've got to take off from pretty much 0 boat speed. So if you're designing foils in particular to work through a range, they're going to be quite different to the foils that you would design if you were just trying to achieve a top speed. We basically want to get the best lap time, not the best top speed. Yeah, the boats are pretty fast, but they're not. Their primary objective is not to be an all-out speed machine. Their objective is to be a fast lap time boat.
From a design perspective, what challenges do you begin to experience as the boat speeds increase to that degree?
The main wall you hit is cavitation, which as you go faster and faster, the water pressure on the foils gets very low. The water accelerates over the surfaces of the foils and effectively boils on the surface of the foil. And when it does that, it changes the shape that the rest of the water sees. Basically, the bubbles that it creates become part of the foil in terms of what the water flowing onto the foil sees. So it changes the shape of the foil in a really unhelpful way, and that starts to happen as you get to around 40 knots. Drag increases really quickly, and then as you sort of get well into the cavitation region, you hit a wall where you just can't get past, because however much drive force you have behind it, the drag just goes higher and higher. There are things you can do to counteract cavitation in the design of the foil sections, but then they've usually got compromises in lower speed areas. So it's about, again, picking those trade-offs, deciding where you want to focus your attention, whether it's sort of at the lower speed takeoff or whether you design your foil to cavitate a bit later at the expense of the lower speed.
The team have already bagged their first capsize back in December while out testing. It was a slow affair. As they say, if you're going to get one out of the way, it was a good way to do it. What did you learn from that?
Yeah, it was a good capsize to have, because it was in pretty benign conditions. It happened slowly. We had a plan for what we would do in the event of a capsize, and pretty much everything went to plan. Hopefully there's not too many more of them, but if there are, we'll be better prepared now that we've gone through the motions. What did we learn? I think we learned generally that our plan for how to right the boat was good. There'll be a few tweaks to that. We were able to carry on sailing straight away, so all the sort of waterproofing on the electronics and the hydraulic systems was all good, despite a lot of the electronics being underwater for a little while. And I think it's a good result. The class, when we conceived it, was a class which could capsize. But the intention was that the yachts would be built in order to be able to withstand that without damage in the event of a low-speed capsize, and we've seen that held true.
While Emirates Team New Zealand have been testing at home in Auckland, Ineos Team UK have been testing initially in home waters and then in Sardinia, in Cagliari, the site of the first World Series event. So I also asked Nick Holroyd the same performance-related question about their AC35. Nick, what sort of speeds are you reaching, and what sort of speeds do you think might be achievable?
I'm not sure we really answer those questions, do we, in a format like this? Look, yeah, I think peak speeds and things are not specific, particularly meaningful to a result, really. These boats will be capable of speeds approaching 50 knots for sure. They've got a huge amount of riding moment. They're very efficient. The issue to some extent comes back to the point about having a fixed measurement certificate. So if you had multiple foils where you could tune the boat to a specific wind range, then yeah, you could really wind one of these things up and send it. Producing a foil that goes from light air takeoff all the way through where you expect to spend under the probability curve that we live under of the wind statistics in Auckland at 4 o'clock in the afternoon, where's your kind of meat and potatoes in terms of 10 to 15 knots type range where you really know you have to perform. And then you've got this kind of upper wind limits being bandied around of 23 or 24 knots. The statistics at that end of the bell curve are small, and so you don't put a huge amount of effort into that end of ultimate performance, I guess. But if you're talking about a 12 knot average wind speed in Auckland and you're quick upwind in those conditions, then it's going to be a powerful combination, I think.
You ask a designer a simple question. It required one word answer. For the sailing fan, we've not seen a great deal, and everyone's beginning to think, what it might look like in Cagliari. What kind of speeds will they reach? And so we were just really after a kind of a tease to what we can expect.
Well, certainly the boats are capable of 3 times wind speed on the race course at VMG type angles. So you kind of multiply those up and you get to high speeds. You ultimately run into the cavitation wall and become speed limited at the really high ends. But phenomenally quick boats.
And Marcelino, American Magic have had a great run of training over in the US. How happy are you with the results, and what sort of speeds have you been getting out of the boat?
Well, yeah, to me, the most impressive thing about these boats is how fast they can go upwind. You're above 35 knots many times and not too much breeze. upwind, they're just incredible how fast they are. Obviously, we don't design the boats for maximum speed. We design the foils to be all round. So you could, in theory, design boats that go much faster downwind, you know. And but to me, the most surprising is the way, the most impressive thing about these boats is how they go upwind. That's pretty amazing.
So while that's a bit of a lowdown on the current AC75s, the teams are all also building a second race boat to be used in the Challenger series for the Challengers, and then the Cup match for the Defender, and the one successful Challenger in the early part of 2021. With that in mind, I asked Dan Bernasconi what decisions are being made now that would have implications for the build of the second race boat.
Yeah, the Cup's 14 months away, but it takes around a year to build a boat. So although the racing is far off, our design decisions are happening right now. And the very first thing that you have to decide and commit to in the design of the yacht is the shape of the hull, which is obviously a really, really important decision to make. So when you start building a yacht on day one, the shore team take that shape from the design team, and they construct a plug. From the plug you make a mould, and from the mould you build the hull. So although the Cup's 14 months away, teams will have already committed to that hull shape and will know exactly what type of yacht they will be racing in March 21. And from then on, the decisions just don't stop. There's every week we have deadlines on all the various components of the yacht, and it's just relentless, the number of drawings and amount of engineering we need to get through over the next few months. And really that'll be ongoing right until the end, because there's every component has a different lead time. The yacht as a whole is around a year, but then foils and masts are a few months. So, and there's small details that maybe a day. So you can be designing right up until the end, and you've just got to keep on top of the schedule and make sure that all those decisions are made with enough time to get components built and tested in time for the race.
So each team under the rules gets to build two boats. How different do you think your second boat will be to your first boat that you've built?
There'll be a huge amount of anticipation around the launch date of team's second yachts. There's 4 very different yachts out there now. Everyone is looking very closely at everyone else's boat and wondering what aspects of those yachts might be better than what they've got on their yacht. So whether there'll be a sort of convergence to more similarity between the final race yachts or not, it's really hard to pick. I think if the class went on for several generations, then inevitably everyone would work out what the best solution is. But just in a second generation of yacht, who knows? I mean, maybe one camp will be looking at the other and think they should be going in that direction, and the second camp will be looking at the first, and there'll be a sort of a switch. It's really hard to pick, and really exciting to look forward to that sort of reveal in a few months' time when we get to see which way teams have gone.
All the teams then have already made decisions and commitments regarding the nature of their second boats. But one of the very different things it seems about this AC class rule, and it's a byproduct of the foiling nature of the monohulls, is that while out sailing, a huge amount of the external design is on show. All the teams are engaging in what everyone refers to as recon, reconnaissance of rival designs. So I was interested to know how much notice the design teams took of their rivals' innovations. Lunarosa's Martin Fisher answered this query first, as I asked him about the availability of information from watching the other teams out on the water.
It is available, I agree with that, and of course from photos we try to redesign their boats, their foils, the rudders, everything as much as we can. For sure the others do the same. And then we run simulations, put it into our VPP, into our simulator, compare it to our boat. So we can push pretty far there. But with the sections we have difficulties, the foil sections, because we can only guess them from photos. And to give you an idea, when we optimize foil sections, we are not talking about, not even about millimeters. Sometimes we are talking about less than a millimeter difference between a good foil and a bad foil. And that's something that we cannot measure from photos. So although it's all visible, this is still somehow hidden. And the other aspect is the foil control systems. Also there we can't see any, or very little. And there we don't know what they're really doing. We can only guess from the foil shape, from what we can see from outside, but it's guessing.
With all that in mind, Martin, I mean, all of the teams are currently making, the big decisions on their second boats. Can we anticipate with the Mark II of each boat, the designs will become more similar? I mean, what are you expecting from the next generation, and what are we going to be seeing in the next race boats?
It's very difficult to answer that question because all the teams have been running optimizations to get the hull shapes, the foils, and so on for the first boat. And the outcome or the result is, the optimization is a sort of technical process. So it's not easy, it's very complicated, but it's a sort of technical process. And the result that you achieve depends not so much on the optimization algorithm or the method that you use, but on the assumptions that you make. And if teams make different assumptions on what is important or how to qualify a good boat and a bad boat, then also the outcome is different. And whether the next boats, the shapes of the next boats will converge or not, depends whether teams will agree more than now on the assumptions. And if that is the case, then also the shapes will converge, but maybe not. I really don't know. It's a very difficult question because we haven't raced against each other yet, and we all had to commit for our second hull before the first racing. So it's very difficult if teams change their mind or not. Difficult to say if teams change their mind or not in terms of the basic assumptions.
What different things do you think we might see in the next generation?
Ooh, that's complicated. I think teams will work a lot on aerodynamic refinements. For sure, lots on systems, control systems, although we won't see them. But as a consequence, if the control systems change, then also the foil shapes I expect will change. So maybe we can see some changes there as a consequence of the control systems. But that's just a guess, I don't know.
Team Ineos UK. Nick, how much weight does your design team put on the work of reconnaissance in this process? How big a part is being able to see so much of the other team's work?
I mean, you got to ask yourself what wins the America's Cup, and ultimately you need to amass knowledge about this class and how it operates, how it sails, and then ultimately you've got to execute your last iteration as well as you possibly can. And so everybody's doing it to everybody, and it'd almost be disrespectful if they weren't. I think I think you look at it as a source of knowledge. As you say, there are really different solutions out there, and we can't test all of those. We can test those solutions numerically here, but to see some of the subtleties of the behaviour, we go and watch for sure.
I mean, I often think though that some of the differences are so small that you're talking, millimeters, I guess, on things and weight distribution. I mean, can you actually see those kind of minute differences?
Yeah, I think, and as I say, I think the differences right now are bigger than that, and I think we're all looking to try and get, you first and foremost have to get the big ticket items right, and then there's a kind of, I think, ultimately a convergence process, because people start thinking about, how do I beat someone, and if you look at someone and go, actually, they're really strong in these conditions, but this is perhaps their Achilles heel. How would I line myself up against people that think that way? How would I line myself up against guys that are thinking this way? And I think that's what drives the convergence process in the class. So in order to engage in that process, you have to understand what other people are thinking, and there's multiple layers to the whole reconnaissance thing. There's actually being there and watching them and how they're performing and gauging their stability and their manoeuvring and all these things. There's the sort of photogrammetry of what do we think their wing area is, how are they distributing it, and ultimately the most valuable layer is probably what were they thinking as they designed it. What were the factors they had in mind, and what were the relative values they placed on those factors, and how does that impact my thinking?
Nick, making decisions all the time on the shape and design of the eventual Cup boat, how close do you think each team's Mark II will be to the design of their first boat?
I think second boats will vary quite a lot. As I say, we're more information rich than we were. We got a class rule for in the 1st of April 18, and we committed to building boat 1 in September. So you had 5 months to try and build a set of tools, understand the problem, what have you. You've had all the experience of building it, B, launching it, C, now sailing it and manoeuvring it and what have you. And you've been refining the tools, and you know more about the time of the day, the venue, all these factors which drive the mean wind speed that we're expecting, for example, the wind statistics around. So yeah, from our side, the knowledge gap between where we were when we signed off boat 1 to where we were signing off boat 2 to where we will be ultimately signing off our final set of foils, those are really big steps. And so you'd almost be disappointed if you ended up in the same place, to be fair. So I think we'll see really big differences.
American Magic's Marcelino, tell us, as the teams all begin to think about the build of their second boats, what do you think the trend will be? Will we see some of the design concepts merged together, or does every team just stick with their very own design direction?
Well, I don't really know what other teams are thinking, but I suspect there will be some degree of convergence. However, I'm sure that we will also see new ideas in that respect. For sure, we will need to improve for what we have now to be able to be competitive. So I wouldn't discard some new concepts or some new ideas coming into the whole design. Yeah.
There's a lot more to look forward to as all 4 teams finalise the designs of the race boat that they hope will eventually prove victorious in Auckland. To summarise, we wrapped up each interview with a couple of closing questions to each of the design chiefs. First up, Luna Rossa's Martin Fisher. So Martin, we've looked at some of the separate design aspects of the AC35. I mean, getting all these elements together is a massive ask. How big a design project has it been?
It has been a very big design project. So we have been working for, actually since January 2018, we have been working full on, so with a team of more than 30 people, and really full time. And full time is more than 5 days per week and more than 8 hours per day. I don't know how many hours that was, but it was a big task. Also because it was very it was very unique this time, because we created basically a new type of boat. So there's no experience. We could not use any empirical models or experience. We really had to base everything on physical models, and that was a very big effort.
Martin, you've been involved in this game a long time. What area of design do you think is going to be the winning ground, that winning edge in Auckland come 2021?
Control systems will be very important, and because control systems have a big impact on all the rest. So if you have a good control system, then you can, or a better control system, you can push your foils further and so on. But also foil optimization, the rig, well, in the end, everything will be important. I don't think that there is one point that really sticks out. They're all important. Difficult to say which one it is, but if I had to pick one, I probably would go for control systems.
Nick, for the design team at Ineos, just how big a design project is this AC35?
It's the only one we've got. Look, yeah, it is a huge, hugely technical boat, and trying to keep sight of the fundamentals, get the big picture right, and then add the really nice detail on top of that. Look, it's how long is a piece of string? This is it's all the hours in the day and then some.
For you, Nick, what area of design do you think is going to give Team Ineos UK that edge?
Ultimately, I think how consistently these boats can be sailed and how close to optimum these boats can be sailed is going to be a big deciding factor. You know, you saw the Kiwis in Bermuda. Their tacking and jibing consistency from very light air up was really impressive. So I think understanding how to keep the boats at optimum and having the systems to manage that. You know, yes, you need to design fast foils, and yes, you need good sail shapes, and you know, you can't get any one thing really wrong, but consistency will be a huge driver.
Marcelino, looking at the whole project, pulling it all together, for the design team at American Magic, how massive a design project is this AC35?
It's quite huge, to be honest. You know, we thought the Cats were complicated boats, but this is on a totally different level. You know, in all areas. You know, we're using more resources, more people, and at the end of the day, more money than we ever thought. You know, and compared to the last times, these boats are bigger. You know, as I say, they're more complicated, and in many of the areas, or most of the areas, they're new designs. So it's becoming a very, very complex project.
And for you, Marcelino, taking everything into account, what area of design do you think is going to give the winning edge in this Cup?
Well, we always try, not just with the America's Cup boat, but with every boat, to improve on every area, you know, and little improvements usually make a big jump in performance. But if I had to choose, I mean, we've talked about the appendages and how the rule is pretty restrictive in the way it deals with that. But the hull, on the other hand, is very open. You know, the hull surface, and we could see some interesting developments in that area that make a difference.
It seems appropriate then to leave the final word with the design architect of Emirates Team New Zealand's 2017 Cup win, Dan Bernasconi. As a man who most recently knows what single factor can win the America's Cup design race.
It's pretty hard to pick, and it's for a new class and first generation of boats, it's not at all obvious where the battleground is going to be fought, and it could be quite weather dependent. If the Cup ends up being raced in, say, 6 to 12 knots, then a team that's got a hull which is really optimized for takeoff and is able to get up on the foils earlier, could leave another boat standing. If on the other hand the breeze is range of say 12 to 24 knots, then all the teams will be able to get up on the foils quickly, and it will be far more about the straight line performance and getting through manoeuvres well. And then it'll be more about the design of optimum shapes on the foils, the rudders, and the sails and the rig package that are important. But I think with such a new class, maybe you don't have to be the best in every single area, because I think in each area some people will get it right and some will get it wrong. So it's maybe more about just not really screwing up any particular area. And if you're pretty good on the foils, pretty good on the hull shape, pretty good on the rig, pretty good on the sails, then maybe you're going to be in with a pretty good shot.
So there we have it, the 4 design teams from the 36th America's Cup, all giving us a glimpse inside their cutting-edge world as they all tried to build the world's fastest ever racing monohull. It's an incredibly exciting time in our sport. We've said it before, but look at any level of sailboat racing now. From foiling windsurfers through to GC32s, foiling Imoca 60s or Olympic NACRA 17s. And there's a massive movement towards ultra-efficient, high-angle, foiling race boats that all owe in some way a debt of thanks to the work that goes on at this level. It's mind-boggling at times, but the work of the design teams at the Cup is an inspiration in our sport, and it'll be so exciting to see the results of their innovation and perseverance racing around the Hauraki Gulf in 2021. I have to say a big thanks to Nick Holroyd and Ineos Team UK, and to Martin Fisher and Luna Rossa for allowing us the time to get their interviews done. To Dan Bernasconi at Emirates Team New Zealand, and to Hamish Hooper for the recording of our interview with Dan. And to Marcelino Boaten at American Magic, and Will Ricketson for making that interview happen. A big thanks for all of your time and effort. Thank you. To Tim at Vertigo Films, of course, for pulling the whole thing together. As ever, a big thanks, Tim. And to you, dear podcast listener, thank you so much for tuning in. It's great to have you along for the ride. Do let us know your thoughts on this very different edition of the podcast. It'd be great to know what you think, whether you'd like more editions like this, or whether you prefer the one-on-one format we're more used to. Don't forget to like, subscribe, or give us a rating. It all helps in the big podcast scheme of things. Until next time, thank you so much for listening, and sail safe, everyone.
This is Castle 1, race officer speaking.
Pressure coming here, pressure coming.
We're 1.5 below.
Stand by, 2 dives here, boys.
We're looking at 10.5 to 42. This is Castle 1 standing by. Out.